Today we are going to talk about a basic lighting system. Every lighting system is similar and usually has 3 to 4 components. It has lights, it has a person, it has a console, and a dimmer. Everything starts with this: one person and a lighting console. The person thinks about what he or she wants to do. This goes from their heads to their hands to the lighting console, and the console then sends the signal to the dimmer. Always remember the direction of the information. The lights plug into the dimmer. The dimmer and the lights will be on stage. The dimmer needs one thing, and that is power. Sometimes a lot of power. Quite often it's a 100 amp 3-phase, and sometimes it's a 400 amp 3-phase. It's really that simple. Every lighting system is the same, whether it is a large concert or a high school play. Now that you have a better understanding of a basic lighting system, let's talk about how each component works together. For this video illustration, we have a 12-channel dimmer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Down here you have a 12-channel lighting console, and it also has channels 1 through 12. Let's say we have a lighting fixture up here. It plugs into dimmer 1. This lighting fixture down here plugs into dimmer 12. Every time channel 1 is turned on, it talks to dimmer 1, which turns on whatever is plugged into it. If you turn on channel 12, it will turn on whatever is plugged into dimmer 12. This is the simplest form of how the components work together to create a conventional lighting system. Now we're going to talk about how the signal gets sent from the console to the fixture. In the old days, we used an analog signal, and as the industry progressed, it went into the AMX signal. We won't talk about these too much because these systems are pretty much dead. These both would send the signal from the console to the dimmer. Years ago, manufacturers were making consoles and dimmers that couldn't speak the same language, therefore couldn't communicate with each other. We had little converter boxes that would interpret the language so that the dimmer could understand the command. It was USITT who finally said, "We need to standardize in the world what a lighting system is." When they came to this conclusion, there was DMX. DMX is still one of the main industry standards in lighting today. You can't talk lighting without understanding DMX. During this period in time, all manufacturers started making DMX consoles and DMX dimmers, which eliminated a converter. Now the console was speaking the same language as your dimmer. So a lighting designer could send the signal from the console to the dimmer to the lights without any issues. Now that we've covered the history of DMX, we can talk about it in further detail. DMX is sent through a 5-pin XLR cable. The DMX 512 cable can carry 512 commands or parameters. It can recognize if you have a 12-channel console. You are going to use up to 12 parameters or commands talking to 12 dimmers. Here's your lighting guy. Lighting guy is at the console. Works in a theater with a low budget, and all they can afford is a 12-channel console, which is fine because in this low budget theater we only have 12 fixtures. These 12 channels talk to this 12-channel dimmer, which talks to all 12 of those lamps. Even though this is a 12-channel console, it is still sending out a DMX signal. The signal that is being sent out is more intelligent than just 12 channels because it can understand 512 parameters. The dimmer will have a digital thumb wheel, We dial that at 001, meaning dimmers 1 through 12. Let's say the theater increases their budget and buys 12 more lamps. They need to buy another dimmer. Well, if this dimmer is 1 to 12, this dimmer would be 13 through 24. We only have a 12-channel console because they couldn't afford a 24-channel console to talk to all 24 dimmers. They have 24 lamps, 24 dimmers, and a 12-channel console, which one would think is a problem, but it isn't. DMX can make this dimmer exactly the same as that one by addressing it to 001. Therefore, it mimics this dimmer here. So when I bring up channel 1, it turns on dimmer 1 and dimmer 1 here. So whatever is plugging into dimmer 1 and dimmer 1 is going to turn on. DMX allows you to move numbers around as long as they aren't overlapping. Further example of this. The theater decides to buy a 24-channel lighting console. What we can do is dial the second dimmer 013. Now this dimmer is 13 through 24. This is DMX in its simplest form. Now we are going to talk moving lights. Moving lights are where DMX comes into play because we have thrown around this number 512. And we think, geez, pretty big lighting system. 36 dimmers, 36 channels, and a lot of lights. That's fine because one light takes one command or one parameter. On the other hand, to turn on a moving light that is one command, let's say pan, gotta be able to move it, that's another command. Tilt, up and down is another command. Color wheel, gobo wheel, second color wheel, second gobo wheel. So before we even get started, we have 6 parameters. Most moving lights take about 26 to 30 parameters or commands, which gives us a small window to work with when we only have 512 commands available. Here is your lighting guy and your console. We aren't talking channels with consoles anymore. Let's say we have 5 moving lights, and each of these moving lights have 25 parameters. The beauty of moving lights is that the signal that comes from your console doesn't have to go to the dimmer, because you are dimming these with internal shutters from the console. The data can go straight into the moving light, and then it can daisy chain all of them together. The DMX address of the lights is 001. Every time I bring up channel 1, all the moving lights are going to do the same thing. Now your 5 moving lights have taken up 125 of your parameters. As you can see, a lighting rig with a lot of moving lights is going to eat up these DMX channels very fast. Some of these consoles have different universes. Grand MAs can go up to 8 universes of DMX. Each one will be 512 parameters because they get eaten up very fast. And once they are eaten up, you're done. You still need power, so you still need a moving light distro that the fixtures can get power from. It's all data. If we want to be able to talk to each light individually, this light picks up 1 to 25, and you add another 25, and you're at 50. As you can see, you're going to eat up 125 DMX channels just on these 5 lamps. When people are constructing a lighting system, they can't just ask for a random console. They have to know if the console is sending out enough intelligence to be able to talk to everything. That is DMX, moving numbers and parameters. This video will be about the basics of rigging. It is always an interesting feat to see how it is done. I will give you a quick explanation how. A lot of people go see concerts and they see a large lighting rig in the air and don't understand how it got there. It's quite simple in theory. What happens at the beginning of any load-in for a concert venue is that the rigger will climb up to the steel structure of the building. They take an elevator or a ladder to get to the catwalk. Down here is where the truss gets built. The rigger will be up here. He will look at the structure of the beams and know what they are rated for. 500-pound load, 1,000-pound load, 2,000-pound load, or whatever it may be. It takes two riggers to get the job done. The guy in the air and the ground rigger. The ground rigger has a tough job because if this guy drops anything, it could knock him on the head. The ground worker is always wearing a hard hat and is responsible for the other workers in the area to say, "Hey, there's a guy above working, don't come near me." This rigger will tie off a rope and drop it all the way to the ground. The rigger will assemble his span sets and wire ropes and whatever he needs, 5-footers, 10-footers, 20-footers, and attach them to the bottom of the rope. This guy will pull everything up. Now he has all his stuff so he can securely build what is called a point. A concert rig can have 100 points. Some will have 6. Depends on the size of the venue, size of the lighting rig, size of the trussing rig. Now down here, the ground rigger has what is called a chain motor or a hoist. He prepares the motor. Everything requires power. There will be a motor distro attached to power. The rigger will again drop his rope to the ground. The ground rigger will attach that rope to the end of the chain. This motor will have, let's say, 75 feet of chain, which is heavy. This rigger will pull that chain and its hook all the way up. Now you can imagine this is hard work. They are pulling a lot of chain and they can't drop it. The chain comes up and they hook it into the point they built. Now that's hooked in. This motor has a hook underneath it as well. Now we plug that motor in, turn it on, and hit the up button. Every once in a while you'll hear a ground rigger yell, "Chain spill!" Chain gathered up too much and has fallen out of the basket and will come whipping out down to the ground. You don't want a chain falling. Now here is our truss. We attach this motor to the truss, and we also have another one here to attach to the truss with a chain going up to the point. This rig has 2 points, which means there's 2 places where the rigger has created a point to drop a rope to bring up a chain. Now you have these motors plugged into power. You turn it on and these motors start climbing. Now we can attach the lights. They lift the truss to about waist height or head height while it's on the ground here, and the lighting crew comes in and attaches all the fixtures and gives it the okay. The rigger will say, "Truss moving," and the truss starts moving wherever it will live for the show. And during the loadout, the process is the same, just in reverse. That is rigging in its basic form.